Hello everyone, my name is Sizheng. Today my presentation is altruistic and profit-oriented, making sense of rules in Web3 community from Airdrop perspective. First, let's talk about the governance in Web3 communities. With the development of blockchain, the emergence of Web3 has brought decentralized communities into our research. Decentralized communities introduce more challenges, including allocation of power, which is achieved by governance tokens. Hence, an important question is how to allocate tokens. Airdrops are initiated by decentralized application to offer their tokens to previous users in building a decentralized community. Users who have contributed to dApps can receive a certain number of tokens for free. For example, Uniswap has distributed 50% tokens to early users. Next, let's talk about the development of Airdrop. The first is fair allocation. Fair allocation means all previous users will receive equal number of tokens. For example, Uniswap airdropped 400 tokens to all previous users. In order to encourage users' deep participation, some dApps will give different rewards to users according to their interaction. We also call this differential allocation. DYDX is one of them. There are five allocation tiers that depend on users' usage. Airdrop hunters leverage the anonymity of blockchain to create multiple addresses to obtain more airdrop for profit. There are two drawbacks. First, some of them tend to sell the tokens instantly, making a drop of the asset price. Second, the airdrop hunters had considerable power in voting. An example is Juno Network. An entity obtained 9.6% of the total amount of tokens and brought a huge potential security risk to the community. To cope with this situation, some of them have begun to design stringent filtering mechanisms like ParaSwap, CoSwap, and so on. A typical example is ParaSwap. Around 1.3 million addresses have interacted, but only nearly 20,000 of them were airdropped. The first rule is airdrop hunter detection, which is considered from address profile, transaction number, and group size. They decided to assign each eligible user points based on their transaction count and volume and the number of chains. According to points, users receive different airdrop. This method caused widespread concern across the Web3 community. Some early users criticized the ParaSwap and triggered debate on the effectiveness of airdrops. A straightforward way to answer this question is to survey how receivers handle their airdrop tokens. Interview and survey are good at answering why, but many users' profile would need to be collected. It would be challenging to send questionnaire to eligible users by their wallet addresses from the anonymous blockchain community. Besides, conducting user surveys will incur higher monetary costs, especially on the blockchain. Hence, we need a data-first approach to understand receiver behavior. Based on these considerations, it would be wiser to extract the information we need from open source data to analyze the detailed user behavior. In this paper, we take ParaSwap as an example, trying to examine how airdrop receivers handle rewards, investigate the effectiveness of airdrop strategy, and identify airdrop hunters' behaviors. Next, let's talk about user transaction flow model. We adopt hierarchical clustering to identify clusters that share similar behaviors. Our clustering algorithm is based on a similarity graph, where each node represents an address and each edge represents a similarity weight between two addresses' transaction flows. We use the transactions to extract operation type of addresses and reformulate an operation flow as sequences. However, the difference in the length of operation flows makes it difficult to measure the similarity. To solve the above problem, we count the auction types in which each sequence and choose weighted cosine distance to calculate similarities. We employed the agglomerative hierarchical clustering. Each cluster represents certain type of behavior pattern. Okay, next, let's talk about the cluster results. The results describe their behaviors belonging to the corresponding cluster with very clear boundaries. And we select 3 indicators, the balance, staking, and liquidity, to discuss the distinction between the two groups in terms of duration period and the quantity held. Figure A shows that Group 2 has a wider distribution than Group 1, and in Figure B, Group 2 tend to stake more tokens and provide more liquidity than Group 1. In conclusion, addresses with purchasing behavior are more likely to be involved in more sustainable financial activities. ParaSwap has 3 levels of rewards for early users. By calculating the proportion of rewards receivers at different tiers levels in each cluster, we obtain this figure. From proportion of 5,200 and 10,400 in cluster 8, 9, 12, 13, and 14, we can obtain that users with more tokens are more likely to participate in altruistic behavior. This shows the effectiveness of the differential airdrop. Okay, next part is the network analysis. After discovering the addresses' behaviors, we attempt to find the hunters and conduct analysis about them. So we need to answer 2 questions in this part. In order to answer the above 2 questions, we construct 2 transaction networks. The first is PSP transaction network, and the second is external transaction network. External transactions are initiated by user addresses, and they can be direct transaction between user addresses or function calls to smart contracts. Besides, the difference in time period can help us explore the difference in hunters' behavior before and after airdrop. In order to detect the existence of airdrop hunters, we choose PSP transaction network. Components detection is a good way to solve the above problem, and the component is a collection of addresses for which PSP has been transferred. The detailed information are summarized in this table. We have conducted detailed exploration of the token transfer in PSP transaction network. We find 2 special path patterns, the chain in the left and the sunflower in the right. The airdrop hunters still exist. Hence, we will explore how they invade screening mechanisms. To address this issue, we retrieve the information from PSP transaction network and match them to the external transaction network before airdrop. They are not fully connected by edges in the left figure. Based on the strong association of these addresses in the right figure, it's reasonable to believe that other discrete nodes are founded by the centralized exchanges. This small group's central consists of 4 non-airdrop addresses, the red nodes in this figure. The other members, the blue nodes in this figure, were not related before airdrop, but they were all funded by these 4 sponsors through direct transfer for airdrop eligibility. Community regulators can barely identify airdrop hunters' behavior like this, unless they look farther than their second degree of association. Okay, the next part, let's talk about the conclusion. We find that more than 38% receivers only sell airdrop rewards directly, and less than 6% receivers buy more tokens. Besides, we find that differential allocation is effective because addresses with higher rewards tend to buy more tokens or stake them to participate in governance. Meanwhile, they have lower attrition rates. Next, we explore the limitation of this method. We find the clear airdrop hunters still exist. In PSP transaction network, we find 2 paths of token transfer, the chain and the sunflower. Besides, we find 2 ways in which hunters escaped screening. Okay, the next part, let's talk about the discussion and the future version. We conclude our results as challenges for future research. The first is slowing down the path of financialization is to separate governance from tradable tokens. First, we consider that a new ERC token standard could be proposed to create non-tradable voting tickets for governance. Another incentive mechanism can be applied in the form of rewards, engaging the voting layer. Improving the model of community governance and empowerment is another possible direction. We try to show that exploring HCI is a blockchain from other parties. We proposed a multi-staged airdrop model that releases the second round rewards based on the role identification of the initial round. Understanding users' behavior and values is crucial for incentivizing and building a community. First, a large-scale study on address profile would be helpful to understand the members in decentralized communities. In the future, we could opt more information of decentralized community if a quality study is conducted.